on perfect square trinomials, and we're going to use those to complete the square. So what I want to do is I want to talk for just a minute about how we briefly talked about it, but I told you you could still use the box, but you need to be able to recognize this pattern. So at this point, now you have to be able to do this. So perfect square trinomials. All right, so perfect square trinomials have 3 criteria. Again, this is review. We've already done this, but I'm going to go through it one more time. We have 3 pieces. Okay. The second sign has to be a plus. That's criteria number 1. Second sign is a plus. Oh, I did. I have an extra O in it. Thank you. Trinomials. Trinomials. There we go. The second thing that has to happen is that the ends here, I'm going to put a number 2 here, have to be perfect squares. What are perfect squares? What does it mean to be a perfect square? Like 4. Give me another one. 9, 16. Oh, I was supposed to point that list is gone. Anything that can be multiplied by itself twice gives you the perfect square. So I've got the second sign as a plus. The ends are perfect squares. And here's the tricky part. The middle, if you take the square root of the ends, okay, so if this was a squared and b squared. So if you took a and multiplied it by b and then doubled it, that has to be what's in the middle. Okay, square root, multiply, and double has to give you what sits in the middle. If it meets those 3 criteria, then it's a perfect square trinomial. The first sign could be plus or minus, it doesn't matter. Okay? And we use them to recognize it because they're easy to factor. They're super easy to factor, and they're also going to be easy for us to solve our equations with. This is probably the toughest section in this chapter, so make sure you're paying attention as we go. I'm trying to give you as much background as I can before we actually get into completing the square.
What is all that up there? I have no idea what you just said.
That's a special pattern. It's perfect square trinomial.
That's the pattern I need to use to answer all these problems.
Yes.
All right.
All these problems. So the 3 things we're looking for: second sign is a plus, the ends are perfect squares, and the middle, if I take the square root of the ends, multiply them together, and double them, I get what sits in the middle. So I'm going to give you a couple examples, and I want you to tell me yes or no if they're perfect square trinomials. Remember, we've done this. Is this coming back to you a little bit? What? Yes, we've already done this. We're going to use these to do something else, but I kind of wanted to refresh you on perfect square trinomials because my gut says you probably don't remember. Actually, I'm going to make this. All right, so I got 3 examples. What I want to do is I want you to tell me yes or no, is it a perfect square trinomial? And then we're going to talk about how we factor it. So the first one. Yeah. Yes. So let's check off our 3 things. Number 1, the second sign's plus. Number 2, are the ends perfect squares? Yes. And number 3, perfect squares. Is there something that times itself twice to give you 36?
Yeah.
Is there something that times itself twice to give you x squared?
Yeah.
Yes. So what times itself twice to give you x squared? 1x. What times itself twice to give you 36? 6. If I multiply those together and times it by 2, do you get what's in the middle?
Yeah.
Yes. That tells me it's a perfect square trinomial. So yes, this is a perfect square trinomial. Now the question is, does anybody remember how you factor a perfect square trinomial? What did you say? Well, you don't have to box the special patterns. You could put it in the box. You absolutely could. But on this one, since it meets those three criteria, you can take the square root of the first number, the first sign, and the square root of the last, and square it.
I just found it all.
Say again?
I just put it all.
Oh yeah, I remember.
Put all what?
That's like last week.
Times 2 to get the middle, yes. Yep. How about the second one? Yes or no?
Yes.
I hear both.
Yes.
Yes, no, maybe so. Second sign of plus, yes or no? Yes. Are the ends perfect squares? Yes. Is the middle one, if you take the square roots of the ends, multiply them and double them, do you get what's in the middle? Yes. Because what's 2x and 7 together gives you 14 and doubled gives you 28. So yes. Factor it then. How does it factor?
2x plus 7 squared.
2x plus 7 squared. Easy enough? Yes, that's the factored form.
The third one is no.
I thought I was trying to find the answer.
We're factoring it. We're not solving it. We're going to use this to solve, but right now I need you to be able to recognize the perfect square trinomial.
I just need to know, can I just times all that, but put it times instead of do that square bullshit?
No, you have to do this.
I ain't doing that.
This is the goal. This is the goal. Look at the last one, yes or no?
No.
No.
Ooh, no, why?
Because when you get 4x times 2 and 8x, you don't need it for the middle number.
It would need to be an 8 in the middle to work. If that were an 8, how would it factor?
X plus 40 squared.
So on your sheet, you have some examples on here. I wanted you to have this that you could use, that you could walk through. There's in the first square up there, there's some patterns in variable form that it gives you. And how we actually go through and find them. So example 1 on your sheet here is x squared plus 12x plus 36. So is it a perfect square trinomial?
Yeah.
Yes, it is a perfect square trinomial. Second sign's plus, x and 6 together give you 6x, double give you 12x, so it factors as, we just did this one, didn't we?
Yep.
Sorry. The one on the back we have not done. 9a squared minus 6a plus 1. Yes or no, it's a perfect square trinomial? Yeah. Second sign's a plus. 3a and 1. 3a doubled gives you 6a, so how does it factor? 3a, first sign, 1 squared. Everybody see what we're doing? Okay. So let me ask you this. Let's go backwards on it just a little bit. Let's say I had x squared plus 8x, and I want to know what I need to put in the blank to make it a perfect square trinomial.
4.
You say 4? 16. So you're doing a little formula in your head, and I don't know if you realize what you're doing yet. What did you do? How did you come up with 16? Close. What?
You thought about the square root.
You thought about the square root and what you needed. I want to generalize a formula here. Let's see if you can make a relationship. Let me give you another one.
No.
Close. You're very close. 25. 5 times x doubled. Let's do another one. It's got to be a perfect square. Remember, the ends have to be perfect squares. 36, 6 doubled would be 12. Somebody said it, I think. 100.
What?
Who said that? Good job. That's what I wanted you to get at. I wanted you to do enough that you picked up on the pattern. You take half of the middle number and then you times it by itself. So if I go back to my ax squared plus bx plus c, okay, to find my c, and I'm going to call it a good c because it's going to make me have a perfect square. To find a good c, I take b and divide it by 2 and square it. Yes?
Right.
Everybody's in agreement? Okay. No?
You gonna give us homework, bro? We ain't even been doing this in what, 10 minutes. We go at 10:30 now.
Bryce, do you have to whine about everything? Okay, that is your, oh my gosh, I couldn't find the page because I pulled it.
We're gonna have homework for that.
Now, yeah, but it's not much. Here's what I want you to do. This is exactly what your homework's going to look like, okay? In fact, I'll do one with you. Page 54. Here's what I want you to do. I want you to find the value of c that makes it a perfect square trinomial, and then I want you to factor it.
Alright.
Okay?
4.
No, it's not.
Boy, how you get
Hey, don't listen to him. Don't listen to him. Everybody's trying to learn it. They get mad at you. All right. Remember, the little formula we just came up with, take half of the middle number and then square it. So what's going to be my good C here on the end? 9, because I take 6, divide it by 2, and then I square it, and that gives me 9. Is everybody in agreement?
No.
Why, Bryce?
I don't understand what you just didn't do.
Take the middle one,
Yeah.
take half of that, and then square it.
Where am I gonna put it at?
You're going to put it in place of the C. You're finding the number that's forcing it to be that's forcing it to meet all 3 of those criteria.
Why is B freaking over 2?
That's half. That's half. That's how you do half. Cut it in half, divide it in 2.
Ask me what B is like.
B, this is, remember your ax squared plus bx plus c? Now how does it factor? So the problems in your homework come in 2 parts. Part 1 is to find this number. Part 2 is to find this.
We ain't never gonna be done with factoring.
No, we don't. We never get done with factoring ever. Even in our last chapter, we're still factoring.
That's annoying. I hate factoring.
Let's do one more of these. Actually, I want to do 2 more. I want to do one that's an even number and one that's not. All right, Bryce. Find the C that makes it a perfect square trinomial and then factor it. Yes. Half of 22 is 11, and 11 squared is 121. That's what I needed to find first. Now what? You look confused.
Yeah, no, I don't understand what you're doing.
I'm taking the middle number, putting it over 2, and squaring it.
Basically, you take the half of 22, and then with that number, you just times it by itself.
11 times 11.
Yeah, why don't you do that? Why do you make life so complicated?
Factor it.
Times that.
X plus what? 11 squared. Now I want you to notice something whenever you're doing this, because I'm getting ready to give you one that's not a nice even number. When we do the square root of C, it's this number before we square it, right? When we factor it. So what happens when I give you one like, okay. This.
They're gonna be -30. You're gonna times that, right?
You took the square root of 9. I don't want you to take the square root of 9.
You're gonna divide.
Half of 9 divided by 2 and then square it.
So it'd be 9.
4.5 squared, but I'm going to leave it as a fraction because it's going to make it easier for you, and I'm going to show you why. I can square both of these, so I get 81 over 4. Okay? That's my C. But my question is now, how do I factor it? Remember the square root of the first, right? First sign. What's the square root of this? 9 over 2. It's what I got whenever I divided by 2.
Oh, and that's the answer?
And that's the answer. I want you to see that you're not really doing any more work when you get it factored. You're taking this here, you square it to find C. And you're going to have to do that when we start actually plugging into equations and stuff. But I want you to have a good grasp on how to force a perfect square trinomial. Okay? All right.